my camera doing okay over there?
Mm-hmm. I just restarted it.
Thank you. (4.9a squared minus 4.9a squared is 0, so those can go away. Too soon.
Okay, so you factored out an age.
And a 4.9.
Oh,
I guess I didn't really have to distribute my 4.9, but I did because it just made it easier. I could have factored it out right here and then have this and this combine and get rid of just the a squareds, but whatever. I think I did that once before and everybody kind of panicked, so I'll just distribute it and then recollect it. It's fine. So isn't this kind of nice? Now, if it tells us any time at all, we can plug that in and find it.
where did the extra 2a come from?
Because the limit as h approaches 0 of 2a is just 2a, there's no h in there. And the limit as h approaches 0 of h is 0.
Okay, so then why the 4.9 that was
And we're at the 9.8.
Oops! Where'd the 4.9 go? Sorry. So it's,
I didn't
It was
notice that.
9.8.
9.8A. sorry.
I didn't,
9.8.
where's the 2a come
I forgot about my 4.9.
from? Still don't understand where 2a comes from.
2a?
Yeah.
So you factored out the 4.
Because I factored a 4.9 from here.
Yeah.
And here.
Yeah.
So 9.8 divided by 4.9 is 2.
Yeah. I understand.
The h what do you make?
I understand in the equation itself. I don't understand why you're setting it equal to 2.8 or 2a.
Right here?
Yeah.
Because I skipped a step.
Yeah.
So if I redistribute this actually I can put the 4.9 out here. I'm gonna do this. Right, I'm just using my limit laws. Okay, the limit as h approaches 0 of 2a, where 2 and a are both constants, h has no effect on it at all. So that's just, can't forget my 4.9 now. That's just 2a, because that limit has no h in it. It doesn't matter where h approaches, it's still going to be 2a. And the limit as h approaches 0 of h is just 0.
Oh.
So I skipped all this
I know,
stuff and
yeah.
went straight to
Okay,
it.
I get it. I get it. I guess I'm used to you doing that.
You're used to me showing the limit laws
Yeah,
every
where
time. Yeah.
I do the same thing you just did. Okay,
Okay, good.
Yeah.
That's fine. Got it? Okay, so that is our velocity. That is our derivative. So now it's telling us t equals 5. And all the time up here in all of our definition, we are interested in t equals a. So essentially our time is a. Our a is 5. So I'm out of room on this page. I should have given you more space for notes. Okay, so we want want to know what t equals a equals 5. That's what they're asking for from the very original question. So f of t, f of 5 we want to know. It's actually not f anymore, it's velocity.
Can you scoot it over a little?
Equals 949 meters per second. That's the velocity of that ball at 5 seconds. 5 seconds after we let it go. That's the instantaneous velocity.
Oh, I guess physics class already did that for us.
They already gave you the velocity?
Well, they already showed how to find the velocity in the physics class.
Well, they give you the equation, 9.8 meters per second squared. Yeah, and then they tell you how many seconds.
Except for its vertical velocity. Which makes sense.
So now you know where it comes from. Okay? Okay, cool. Since the observation deck, okay, so now we're back to part B. How fast is the ball traveling when it hits the ground? Since the observation deck is 450 meters above the ground, the ball will hit the ground at the time t, when the position at that time equals 450 meters. Okay, so that is when our position function, 4.92 squared, equals 450.
Can you speed up a little?
Okay, so now we just solve this for t squared. Good news, I don't have to do plus and minus because we're dealing with time. We're not going to do negative time. Okay, so it's about 9.6 seconds. So I'm not really calculus here, except that we just have to know what the position function means. Okay, and so, but it also asks the velocity of the ball as it hits the ground. We know the velocity function now. We are given the velocity function. We figured it out. Right? We can be exact and do this. That one was pretty much pure physics.
Couldn't you have divided 450 by 9.8? Or not, 9.6?
Mhm.
You guys pick the time.
Say that again, Karen?
Hold on. Let me just check something.
Remember you guys.
Never mind.
You okay?
Yeah.
Okay. Good deal. Okay. So we've seen the same type of limit arise in finding the slope
We have more notes?
of a tangent line.
Do
Yeah.
we have more notes?
We're trying
So
to
the
make.
velocity of an object. We're going to think of those words the same, slope and velocity. In fact, limits of this form arise whenever we calculate a rate of change.
5 pages actually.
What? In any of the sciences or engineering. Such as a rate of reaction in chemistry, a marginal cost in economics. So pretty much any time you see this delta symbol, which means change in, if that's a slope, that's a derivative. Kind of cool. Okay, since it occurs so widely, it's given a special name. It's called the derivative of a function f at number a. And we are going to start talking about notation now. Oh boy. This is what it looks like. F prime of a. A lot of times this is called a little blank. That means the derivative. That means you're doing the limit at that time. Or at that date, not necessarily time. Okay, so anytime you see this notation, that's the derivative. That means derivative. Okay, so if we write x equals a plus h, then we have x equals a minus, or x minus a, and h approaches 0, we've talked about that, if and only if x approaches a. So the points are getting closer together is all that's saying. It's so confusing, you know, you've got to add the x's and the a's and the h, and it's so confusing. All that means is we have that x coordinate, and we have another x coordinate, and they are getting closer and closer together. But so that we don't confuse ourselves and go x sub 1, x sub 2, and then really get lost, we call one of them x, the other one we call a. And we say x and a are getting closer and closer together. The distance between the two, we call it h, because that's, I don't know, height, I guess? I don't know. The difference between the two goes to 0. So the points are getting closer and closer together. Okay? So here's our different kind of definition. It's really the same thing. You notice this a plus h is replaced by an x, so our limit as x approaches a is down there as opposed to the limit as h approaches 0. But it means the same thing, right? Because x approaches a is the same as h approaches 0 here. See that? No magic, just substitution essentially. Okay, so let's find the derivative of a function. Here's our function at the number a. So pretty much at any number. So from this definition we just used, f prime of a, which is the derivative of f at a, that's what that means. The limit as x approaches a of f of x minus f of a over x minus a. So the difference in the y over the difference in the x, as the x's get closer and closer together.
What's that? F of x?
That's our definition. Okay. And then they use the definition that they gave us once before, which is this one. This is the one we're going to use. They mean the same thing.
Which one would you use most?
This one. The second one.
Sticky pockets.
When did you use the first
It's,
If you had 2 points or 1 point?
yeah, if you had, I don't know any examples in here actually when they use that one.
Is f of
So
a,
you're gonna mainly use this one.
is f of a the same thing as f of x? Like, do you plug that thing in? Like on the second one,
Mm-hmm.
the f of a, is that the function?
It's the function evaluated in A.
So you just put a
basic-
in for x?
No, you put A plus H in for X.
No, I know, but it's just the same thing, you just take it.
You're evaluating the function at A here, so that's probably gonna be.
That's the last number you get.
So you put a in for x. Okay, that's just
Yeah,
what I
well-
wanted to know.
That's your tie-in generally. You don't wanna say A for X because look, f of X is this. Back from,
Oh, I'm
this thing.
yeah.
So I don't wanna say we put A in for X because we don't. We put A plus H in for X.
So
there's a diff there.
what goes to f of
You'll see.
a? Okay.
Okay, so we do our good old fashioned pre-calculus. So, everywhere we see an X, we put an A plus H. Okay, f of A, everywhere we see an X, we put an A. Don't forget our parentheses, because we'll lose a negative here. Oops, that's supposed to be an A. Dang it.
Wait,
Just substituted it. So this is just the algebra that I'm kind of cranking through here. Lucky day, isn't it amazing how this happens all the time?
that's cool.
Whoa, what just happened?
Things cancel out.
A squared minus A squared is 0, negative 8A plus 8A is 0, 9 minus 9 is 0.
So 2A H squared is 0.
Make sure you don't forget anything. There's an 8H hiding in here.
Let me see it.
Lucky day, there goes an H. Thank goodness, because that has to happen, otherwise that won't make any sense.
But you,
It's factored out an H. Then I divided it out. Here's my step that I skipped last time. That you guys used to me not skipping it, and then I skipped it. And messed you all up.
so,
So, if they give us an A, you can figure it out. Oh my gosh!
that, I did not do my
What's going
history.
on? Is there an assembly or something today?
No, that's the.
No, that's normal bell.
It is?
Yeah.
Oh, no, 8:30, I was thinking we started. I think we started at 9. Wow, that went
Well,
fast.
so we're going to our locker for 2 hours.
Just to welding.
We were so close, all we had was that.
Actually, to my locker because I have to go behind.
You sure?
Yeah.
Alright. I gotta put the clothes in the car.
Did we work
I
on
had
the
a question
assignment
for
today?
you.
Wait, I thought it was